think about the things that you wouldn't be able to do. Send an email, online shop, find an answer to a question instantly. And that's just the tip of the iceberg. We've come a long way from the very first computer and even the first smartphone. But how much do you really know about their history and evolution? From floppy disk to cloud security, the Acorn to the Macintosh, let's explore how far we've come. Well, today we use computers for both work and play. The computer was actually created for an entirely different purpose. In 1880, the population of the United States had grown so large that it took 7 years to formulate the results of the US Census. So, the government looked for a faster way to get the job done, which is why punch card computers were invented that took up an entire room. Well, that's how the story starts. It's certainly not where it ends. Let's explore everything that happened leading up to that, in between, and after. Today, computers are almost unrecognizable from designs of the 19th century, such as Charles Babbage analytical engine, or even from the huge computers of the 20th century that occupied whole rooms, such as the electronic numerical integrator and calculator. So here's the history of computers. On 1801, Jose Marie Jacquard, a weaver and businessman from France, devised a loom that employed punched wooden cards to automatically weave cloth designs. On 1822, Charles Babbage, a mathematician, invented the steam-powered calculating machine capable of calculating number tables. The different engine idea failed owing to a lack of technology at the time. On 1848, the world's first computer program was written by Ada Lovelace, an English mathematician. Lovelace also includes a step-by-step tutorial on how to compute Bernoulli numbers using Babbage's machine. On 1890, Herman Hollerith, an inventor, creates the punch card technique used to calculate the 1880 US Census. He would go on to start a corporation that would become IBM. In 1930, differential analyzer was the first large-scale automatic general-purpose mechanical analog computer invented and built by Vannevar Bush. In 1993, the PowerPC was introduced. The general proof of work concept was introduced in 1993 by computer scientists Cynthia Dwork and Moni Nauer.
In 1994, PCs became gaming machines as Command and Conquer, Alone in the Dark 2, Theme Park, Magic Carpet, Descent, and Little Big Adventure are among the games to hit the market. And in 1996, Sergey Brin and Larry Page developed the Google search engine at Stanford University. In 1997, Microsoft invested $150 million in Apple, which was struggling at the time, ending Apple's court case against Microsoft, in which it alleged that Microsoft copied the look and feel of its operating system. In 1999, the term Wi-Fi becomes part of the computing language, and users begin connecting to the internet without wires. In 2001, Apple unveils the Mac OS X operating system, which provides protected memory architecture and preemptive multitasking, among other benefits. Not to be outdone, Microsoft rolls out Windows XP, which has significantly redesigned GUI. In 2003, the first 64-bit processor, AMD's Athlon 64, becomes available to the consumer market. In 2004, Mozilla's Firefox 1.0 challenges Microsoft's Internet Explorer, the dominant web browser. Facebook, a social networking site, launches. In 2005, YouTube, a video sharing service, is founded. Google acquires Android, a Linux-based mobile phone operating system. In 2006, Apple introduces the MacBook Pro, its first Intel-based dual-core mobile computer, as well as an Intel-based iMac. Nintendo's Wii Garny console hits the market. In 2007, the iPhone brings many computer functions to the smartphone. In 2009, Microsoft launches Windows 7, which offers the ability to pin applications to the taskbar and advances in touch and handwriting recognition, among other features. In 2010, Apple unveils the iPad, changing the way consumers view media and jump-starting the dormant tablet computer segment. In 2011, Google releases the Chromebook, a laptop that runs the Google Chrome OS. In 2012, Facebook gains 1 billion users on October 4. In 2015, Apple releases the Apple Watch, Microsoft releases Windows 10, and in 2016, the first reprogrammable quantum computer was created. Until now, there hasn't been any quantum computing platform that had capability to program new algorithms into their system. They're usually each tailored to attack a particular algorithm, said the study lead author Shantanu Debnath, a quantum physicist and optical engineer at the University of Maryland, College Park. In 2017, the Defense Advanced Research Project Agency, or DARPA, is developing a new molecular informatics program that uses molecules as computers. And in 2018, up to present, first one is cloud computing, where business organization stores terabytes of data every day, which must be arranged, sorted, and restored. A conventional computer cannot store large volumes of data, which increases pressure to move towards cloud. And second is the Internet of Things. The Internet of Things has turned the dream of smart homes, devices, cars, and workplaces into a reality. And third is artificial intelligence. Artificial intelligence, along with machine learning, will be an unstoppable force in 2018. Fourth is virtual assistants. Virtual assistance technology will be a deciding vote for brand engagement. And 5 is augmented reality. Augmented reality is a technology which places a computer-generated image in front of a user, creating a composite view of reality. And 6 is 3D printing. 3D printing will change the perspective of many industries of manufacturing a product. And 7 is robotic process automation, or RPA. Like AL and machine learning, robotic process automation, or RPA, is another technology that is automating jobs. RPA is the use of software to automate business processes such as interpreting applications, processing transactions, dealing with data, and even replying to emails. The last one is cybersecurity. Cybersecurity might not seem like emerging technology, given that it has been around for a while, but it is evolving just as other technologies are.
Now that we are done with the history of computers, let us now go to the generation of computers. In this video, we are going to discuss the 5 generations of computers. Nowadays, a computer can be used to type documents, send email, play games, and browse the web. It can also be used to edit or even create spreadsheets, presentations, and even videos. But the evolution of this complex system started around 1940 with the first generation of computers and is still evolving ever since. That's why we have now 5 generations of computers. The first generation of computers happened between 1951 to 1958. They used vacuum tubes as their main logic elements, punch cards to input and externally store data, and rotating magnetic drums for internal storage of data in programs written in machine language, which is instructions written as a string of zeros and ones, or assembly language, which is a language that allowed the programmer to write instructions in a kind of shorthand that would then be translated by another program called a compiler into machine language. So I will be giving you some of the characteristics of the first generation computers. The first one is it used vacuum tubes for circuitry, used magnetic drums for memory, were huge, slow, expensive, and many times undependable, solved one problem at a time, and it used input based on punch cards. Let's go now to the second generation. Transistors and batch filing happened between 1959 to 1963. AT&T's Bell Laboratories in the 1940s discovered that a class of crystalline mineral materials called semiconductors could be used in the design of a device called a transistor to replace vacuum tubes. Magnetic cores, a very small donut-shaped magnets that could be polarized in one of two directions to represent data, strung on wire within the computer, became the primary internal storage technology. Magnetic tape and discs began to replace punch cards as external storage devices. So here are the characteristics of the second generation computers. First is that it used transistors. It is faster and more reliable than first generation systems. Were slightly smaller, cheaper, and faster. Allowed assembly and high-level languages. Stored data in magnetic media. Were still costly. And it also needed air conditioning. The third generation of computers integrated circuits and multi-programming in 1964 to 1979. Individual transistors were replaced by integrated circuits. Magnetic core memories began to give way to a new form, metal oxide semiconductor memory or MOS, which, like integrated circuits, used silicon-backed chips. Increased memory capacity and processing power made possible the development of operating systems, special programs that helped the various elements of the computer to work together to process information. Programming languages like BASIC were developed, making programming easier to do. So here are the characteristics of the third generation computers. It used ICs, were slightly smaller, cheaper, faster, used motherboards, and data was input using keyboards. Simplified programming languages, example is BASIC. Now for our fourth generation, the microprocessor, OS, and GUI from 1979 to the present. The microprocessor brought the fourth generation of computers as thousands of integrated circuits were built in onto a single silicon chip. What in the first generation field, an entire room could now fit in the palm of the hand. The Intel 4004 chip, developed in 1971, located all the components of the computer, from the central processing unit or CPU, and memory to input or output controls, on a single chip. So these are the characteristics of the fourth generation computers. First, it used CPUs, which contained thousands of transistors, were much smaller and fitted on a desktop, laps, and palms. It uses a mouse, were used in networks, were cheap, and it had GUI. For the fifth generation, the present and the future, it uses computing devices based on artificial intelligence or AI. They are still in development, though there are some applications such as voice recognition that are already being used today. The use of parallel processing and superconductors is helping to make artificial intelligence a reality. Quantum computation and molecular and nanotechnology will radically change the face of computers in years to come. The goal of fifth generation computing is to develop devices that respond to a natural language input and are capable of learning and self-organization. And that's all for the generation of computers. Now let's go now to the 4 basic computer periods, which will be discussed by Sheena.
Hi everyone, my name is Sheena, and we are going to talk about the 4 basic computer periods. We all know that information technology has been with us for a very long time, and we're all aware how it also made our lives easier and convenient in every aspect throughout all the years. So together, let us learn about how we got to the point we are at with technology today. There are 4 main ages that divide up the history of information technology. First of which is the pre-mechanical age, from 3000 BC to 1450 AD. The pre-mechanical age is the earliest age of information technology. It is in this age wherein the Sumerians in Mesopotamia devised a writing system, the system called cuneiforms. use signs corresponding to spoken sounds instead of pictures to express words. Also, it is in this age wherein humans first started communicating. They would try to use language or simple pictures or drawings known as petroglyphs, which were usually carved in rocks. Furthermore, the first ever calculator, the abacus, was invented in this period after the development of numbering system. Next age is the mechanical age, from 1450 AD to 1840. The mechanical age is when we first start to see connections between our current technology and its ancestors. A lot of new technologies are developed in this era as there is a large explosion in interest with this area. Here are some of the technologies that is developed in this age. First, the Pascalet. Blaise Pascal, a French mathematician, invented the Pascalet around 1642, which was a very popular mechanical computer. It used a series of wheels and cogs to add and subtract numbers. Next is the analytical engine, designed during the 1830s by Charles Babbage. The analytical engine was to have a part called store, which would hold the numbers that had been inputted and the quantities that resulted after they had been manipulated. Next is the electromechanical age, from 1840 to 1960. Now, we are finally getting close to some technologies that resemble our modern-day technology. The discovery of ways to harness electricity was the key advance made during this period. Knowledge and information could now converted into electrical impulses. These are the beginnings of telecommunication. And here are some of its discoveries during this age. The discovery of a reliable method of creating and storing electricity with a voltaic battery at the end of the 18th century made possible a whole new method of communicating information. Next is the telegraph. The telegraph was created in the early 1800s. It is the first major invention to use electricity for communication purposes and made it possible to transmit information over great distances with great speed. Next is the Morse code. Morse code was created by Samuel Morse in 1835. Morse devised a system that broke information into bits that could then be transformed into electrical impulses and transmitted over a wire. Next is the telephone. The telephone was created by Alexander Graham Bell in 1876. This was followed by the discovery that electrical waves travel through space and can produce an effect far from the point at which they originated. These two events led to the invention of the radio by Marconi in 1894. And the fourth age is the electronic age, from 1894 up to present. The electronic age is what we are currently living in. ENIAC, or the Electronic Numerical Integrator and Computer, was the first electronic general-purpose computer. It could solve a large class of numerical problems through reprogramming. The major benefit of electronic switches was that they could open and close thousands of times faster than relay. It is in this age where we have witnessed a lot of technological advancement, and thanks to this advancement, it made our life easier and convenient. And that are the 4 basic computer periods. Bye! See you next time!
E-commerce and e-operations. E-operations. The area of e-operations encompasses the processes of how customer commitments get fulfilled through products and services within companies. This includes procuring products, arranging shipping and transport, and handling production. In short, developing fulfillment system for handling the business that e-marketing and e-commerce generate. Electronic commerce or e-commerce is a business model that lets firms and individuals buy and sell things over the internet. E-commerce operates in all four of the following major market segments. Number 1. Business to business, when a business sells a good or service to another business. Second, business to consumer, when a business sells a good or service to an individual consumer. Third, consumer to consumer, when a consumer sells a good or service to another consumer. And lastly, consumer to business, when a consumer sells their own products or services to a business or organization. Key takeaways for e-commerce. First, e-commerce is the buying and selling of goods and services over the internet. Second, e-commerce can be a substitute for brick-and-mortar stores, though some businesses choose to maintain both. Third, almost anything can be purchased through e-commerce today. And lastly, e-commerce lets firms and individuals conduct business over the internet. E-commerce has also its advantages and disadvantages. The advantages of e-commerce is it is convenience and increased selection. And its disadvantages are limited customer service, lack of instant gratification, and inability to touch the products. Examples of e-commerce: retail, wholesale, dropshipping, crowdfunding, subscription, physical products, digital products, and services. And this ends our vlogging presentation. Until then,